Good morning, my dear students. My name is Ubara Oriva Okemute. I will be taking you on SS1 Mathematics. And our topic for discussion this morning is on plane shapes. Before we go further, we'll quickly look at our objectives for discussion. Now, the objectives are as follows. You will recall and use appropriate formulas to calculate the perimeter of plane shapes. At the end of the lesson, you recall and use appropriate formula to calculate the area of plane shapes. You calculate the length of arcs and perimeter of circle. And also, number 4, calculate the area of sector and segment of a circle. Now, when we talk about plane shapes, we'll make reference to the two-dimensional shapes. Examples of two-dimensional shapes are the rectangle, the square, the parallelogram, the triangle, the circle, the trapezium, etc. Now, you can't discuss these plane shapes without knowing or getting used to the formulas. From our table here, we have already prepared table that has both the perimeters, the formula for finding perimeters and formula for finding areas of various plane shapes. 1. Names of shapes, perimeter and the area. Area of a rectangle is length times breadth. That is the length multiplied by the corresponding breadth. While the formula for finding the perimeter of a rectangle is 2 bracket length plus breadth. 2. As we all know, a square has 4 sides. So the x there represents the sides. The formula for finding perimeter of a square is 4s, which is 4 times the number of sides. 4 times sides. Then the formula for finding area of a square is the sides raised to power 2. So let's say, for instance, you have a square given with side 7. So if you want to find the area, you just say 7 times 7, which is 49. Then we go further to number 3. Number 3, the formula for finding perimeter of a parallelogram is 2 bracket a plus b. And the formula for finding the area of a parallelogram is base times height, or a times b sine theta. This a times b sine theta is that section of a parallelogram that goes with an angle without the height. Because there are some parallelogram that will be drawn for you, there will be no height. So since there is no corresponding height, there will be an angle given to you. So with that angle, you use the 2 sides multiplied by the angle. Then we'll go further to number 4, the triangle. Of course, you know that the perimeter it means, from our basic JS 1, 2, 3, it means the total distance around every given shape. So a triangle, its formula does not have a fixed formula, but if you want to find the perimeter of a triangle, you just simply add all the outer distance, because we define perimeter as the total distance around any given shape. Then the formula for finding area of a triangle, as we all know, is half base times height, or 1 over 2 AB sine theta. That is in a context where an angle is given and the height is not given. So we'll come further to the 5th plane shape, which is circle. Circle is a plane shape that we all know and we've been using right from our basic primary school. Now, the formula for finding the perimeter, which is also called the circumference of a circle, is 2 pi r. While that of the area of a circle equals to pi r square. The pi is given as 22/7 or 3.142 as the case may be. Then that of trapezium, the same procedure applies to the perimeter. You add all the corresponding sides together, you get that answer for perimeter. While the formula for finding area of a trapezium is 1/2 bracket a plus b times h. Now, having understood or known the formulas of finding the areas and perimeters of basic shapes, we will take some few examples to enable us understand the point properly. Example 1. Calculate the area and perimeter of each shape below. All dimensions are in centimeters, cm. A. We have a shape here. You will agree with me that this shape is a rectangle, looking at it. Now, they say we should find the area and the perimeter of the plane shapes given below. Now, what's formula for finding area of a rectangle? The formula is length times breadth. The length is the longer side and the breadth is the shorter side. So if we bring it into the formula, we have 7 times 5, which is 35 centimeters square. If you give your answer as 35 without putting the unit, it's wrong. Because when you are dealing with plane shapes, you must go with a corresponding unit. Every plane shape has their various units. Then we come back to perimeter because we are answering both the area and the perimeter. The formula for finding perimeter is 2 bracket L plus B. Now 2 bracket L plus B will give us 2 into 7 plus 5 because L is 7, the length, while the breadth is 5. If you add it together, you get P equals to 12. So bringing into the formula, 2 times 12 will give us 24. If you observe here, I did not put centimeter square, because we are not looking for the area of the rectangle. Rather, we're looking for the perimeter. So in the case of perimeter, you just put the centimeters or meters or what have you. Then B. We have another plane shape here, which is the parallelogram. Like I said, parallelogram has 2 formulas. Base times height or A, B sine theta. Now, if you see the diagram given to us here, we have A and B, but we don't have the corresponding height. But since we don't have the corresponding height, we were given the angle, which makes our solution simple. So the formula for finding area of a parallelogram is AB sine theta, which is 5 times 8 times sine 63. 5 times 8 is 40. Sine 63 from our 4-figure table will give you 0.8910. Now finding the area to give us 35.64 centimeters square. I am laying emphasis on the unit because the unit is as important as the solution. So our final answer here is 35.64 centimeters square. Then so we quickly go to C. We quickly go to C, the area and perimeter of a circle. What's the formula for finding perimeter of a circle? 2 pi r. So our radius there is 20, which is half of a diameter. P equals to 2 times 22 over 7 times 20, which will give us, reducing to lowest end, we'll have 880 over 7. Then you change it to decimal, which give us 125.7143. So perimeter is equal to 125.7 centimeters to 1 dp. Then we'll go to the area. Area of a circle is pi r square. Area equals to 22/7, which is for pi, times 20 times 20, which gives us 8,800/7, which is still the same thing as 1257.143. So my final answer will be 1257.1. That means this answer is corrected to 1 decimal place. Now we go further into some questions that will also be asked, because not just the shapes that will be drawn for you. Now the question is this. Example 2. The length of a rectangle is 3 times its width. The length of a rectangle is 3 times its width. If the perimeter is 72, calculate the width of the rectangle. The question has pointed out that we are going to be working with the formula for finding perimeter of a rectangle, which is 2 bracket L plus B. Now, looking at the formula, my perimeter has been given to me to be 72 cm. So if I substitute it into the formula, they said the length is 3 times the width of that particular rectangle. So I will be having 72 equal to 2 bracket 3b plus b. So if I add everything together, I will be having, dividing by both sides by 2, I'll have 36 equals to 4b. Then when I divide both sides by 4b, I will have my breadth, which is also the width, to be 9 centimeters. So the breadth of this rectangle is 9 centimeters, because we are asked to look for the width of the rectangle. Example 3. We look at another plane shape again. The area of a trapezium is 14.7 cm square. If the parallel sides are 5.3 cm and 3.1 cm long, find the perpendicular distance. Of course, you know that perpendicular distance is that straight line that makes angle 90 with the horizontal line. So when they say the perpendicular distance, it means we are looking for our height. So recalling our formula from our formula table, we have 1/2 brackets a plus b times h. My area is given to me as 14.7. So equal to 1/2 bracket 5.3 plus 3.1 bracket h, because it's the height we are looking for, which is the perpendicular distance. Then we'll proceed further by clearing the fraction. When we clear these fractions, we have 14.7 times 2 equal to 8.4 times the perpendicular height. So which will give us 29.4 equals to 8.4h. Dividing both sides by the coefficient of 8, we have h equal to 29.4 over 8.4, which will give us 3.5 cm. So our height is 3.5 cm. So those are the major work under the area and perimeter of the various plane shapes. Now the next section we'll be discussing this morning, we'll be discussing the area of sector, length of arc of various circles of the circle. Now we look at length of arc. What is the length of arc? An arc is a short distance on the circumference. The circumference is the total distance around a circle. But when we look at what is an arc is a section from the circumference. Now the length of arc of a circle is proportional to the angle which the arc subtends at the center. From our diagram there, we have our corresponding, we have a circle and the theta inside. L represents the length of arc. Arrow there is the radius. And xy. So coming down, arc xy subtend an angle of theta degree at O. The circumference of the circle is 2 pi r. Therefore, the length of arc of xy is length of arc equal to theta over 360 times 2 pi r. Length of arc. This is our main formula for finding the length of arc of a circle. So when you are given a question, find the length of arc. What is the length of arc? This is a formula you should use to find the length of arc. Theta there is the angle. 360 because the total angle at a point is 360. So times 2 pi arrow. Of course, you know that the arrow there is the radius, while pi is 22 over 7 or 3.142 as the case may be. So we'll take some few examples on length of arc and then we'll proceed. That's example 4. An arc sustains an angle of 105 degrees at the center of a circle of radius 6 cm. Find the length of arc. The instruction will be given, find the length of arc. So when you are given a question, you should ask yourself, what am I asked to look for? You must read the question and understand what you are asked to look for before you proceed. We'll go further by solution. Length of arc equal to theta over 360 times 2 pi arrow. We substitute the values now. Theta is 105 degrees. So I will be having 105 degrees over 360 times 2 times 22 over 7 times 6. Then reducing to lowest term, we have the length of arc to be 11 centimeters. There are simple questions. The major thing you need to understand here is to know the formulas and learn how to apply them. What is theta? What is pi? And what is arrow? What is the L? L means length of arc. So from this question we just solved now, we can see that reducing this our fractions to lowest term, our length of arc becomes 11 centimeters. Okay, let's take example 5. What angle does an arc 6.6 centimeters in length subtend at the center of a circle of radius 14 cm? Use pi to be 22 over 7. The diagram is there for easier identification and clarification. Of course, you know that our formula is L equal to theta over 360 times 2 pi r. You don't solve questions of this nature without stating their formula. The formula is the headway to finding solution to this question. So when you want to solve questions of this nature, you state your formula first. It tells the teacher or the instructor that this student knows what he or she is doing. So length of arc is 6.6 equal to, here we are looking for the angle. We are not looking for the length of arc here because it has been given to us. You can be asked to find the radius, you can be asked to find the angle, you can be asked to find the length of arc. So on this contest, we are looking for the angle. Now, if we substitute further, we'll have theta over 360 times 2 times 22 over 7 times 14 because 14 is our radius. We'll make theta a subject of formula, which is theta equal to 6.6 times 360 times 7 all over 2 times 22 times 14. It will give you, when you reduce to lowest term, theta will be 27 degrees. So this angle that we are talking about that sustains this particular arc is 27 degrees. I want to believe that this one or two examples have helped us to understand how to apply the formula for finding length of arc and finding the solution, both when you are looking for length and when you are looking for the angle. Now we move further. Remember that we are still dealing with perimeters. We are dealing with area. We are dealing with length of arc and area of sector. Now we want to check for the perimeter. Example 6 says calculate the perimeter of a sector of a circle of radius 7 cm. The angle of the sector being 108 degrees if pi is 22/7. If you observe it, we are still discussing the length of arc. Now, perimeter. How do you solve for perimeter? On this type of question, you must solve for length of arc first. You bring in the formula, you substitute. When we substitute, we have 108/360 times 2 times 22/7 times 7. When we reduce to lowest term, our length of arc is 13.2 centimeters. 13.2 centimeters. I did not use cm square because we are not looking for the area. Now, remember, the question is find the perimeter. Now, what's the perimeter? Perimeter means the total distance around a given shape. So, if you haven't gotten the length of arc, what you will do, you will add the other outer parts of that circle, that angle that is subtended, that particular triangle. That is the sector we are talking about. Because we have major and minor sector and the rest. Now, we have perimeter of sector AOB, triangle AOB. We have OA, which is 7 cm, plus OB, which is 7 cm, plus the arc AB. What's my arc AB? Arc AB is what we just solved to, that gave us 13.2. Adding all of them together, we have 27.2 cm square. That is when you are looking for perimeter. Then we go further, finding the area or sector. Each of them has their different formulas. Length of arc has its own formula. Area of sector has its own formula. Now remember, we have come to area. So your unit must be cm square. The area of sector of a circle is proportional to the angle of the sector. We have a circle there that displays the sector. X, Y, O is the center, theta is the angle, Y arrow is the angle there. Which now the formula for finding area of sector is sector XOY is equal to theta over 360 times pi arrow square. You see the formula has changed. So don't miss the formula for finding area of sector to that of area length of arc. There are two different formulas. Area of sector says theta over 360 times pi arrow square. Now let's take example 7. Example 7 says calculate the area of sector of a circle which subtends an angle of 45 at the center of the circle of radius 14 cm. The radius is given, so I think we'll just go straight. Area of sector, from our formula, we have 45/360 times 22/7 times 14 times 14. Learn how to reduce to lowest term, very important. So reducing to its lowest term, the area of sector here, we have 77 cm square. It is now cm square because we are dealing with area. The unit of area is centimeter square, meter square. Good. That's good. Okay, let's take example 8. The arc of a circle of radius 20 cm subtends an angle of 120 degrees at the center of the circle. Use the value of 3.142 pi to calculate the area of sector. You see, the question has been rephrased. It happens, so questions don't go in one direction. So the formula is theta over 360 times pi arrow square. What's our angle there? Our angle there is 120 degrees. So if we substitute, and take note, the value for pi has changed. It has changed from 20 over 7 to 3.142. They are the same thing. They are the same thing. If you change 20 over 7 to decimal, that is still the value of pi. That's the 3.142. So it shouldn't confuse you to say, hey, when do I know when to use 3.142 or I should use 22 over 7? So let's substitute and go further. Area equals to the angle 120 over 360 times 3.142 times 20 times 20. Coming down, we'll multiply all to divide. We will have 1256.8 all over 3. If we divide further, we'll have 418.9. Now, if we round up to the nearest centimeters or to the nearest whole number, our final answer here will be 419 centimeters square. 419 to the nearest whole number. I want to believe that the area of sector is clear. The same thing, you can be asked to find the radius, you can be asked to find the angle. Very good. Now, we'll come to example 9. Example 9, the subtopic here is area of segment. We have a question. Area of segment is combination of the area of the triangle and the area of the sector. So you just subtract them. Shaded, of course, we know shaded portion. Once you find the area of the shaded portion, you find this area, find the other area, you subtract it. So we have a question here. Calculate the area of shaded segment of the circle shown below if pi equals to 22 over 7. Area of segment is equal to area of sector XOY minus area of the triangle XOY. Now, substituting our values, of course, you will see that the angle there is 63 degrees. A equal to 63 over 360 times 22 over 7 times 10 square. The 10 square, because our formula for finding area of a sector is theta over 360 times pi arrow square, minus the area of the triangle, half AB sine theta, which is 1 over 2 times 10 times 10 times sine 63. Now we go further to break our work down. We substitute further, we have 63 over 360 times 22 over 7 times 100, because the square of 10 is 100, minus 1 over 2 times 100 times the sine 63, which is 0.8910. Now, reducing to their lowest term here, we have area equals to 55 minus 44.5, which will give us area equal to 10.45 cm square. This is how you look for the area of shaded segment. Now, before we round up, let's quickly take a review of what we have done so far. Recall, we said you should, at the end of this lesson, you should be able to state and use the formulas for finding the area and perimeter of common plane shapes. Like the common plane shapes here, we have our rectangle, we have the square, we have the parallelogram, we have the triangle, we have the circle, and we have the trapezium. Then further, we still went to discuss how we can apply these formulas, and we saw some few examples there. We went straight again to discuss the length of arc. Length of arc, which is theta over 360 times 2 pi r. And we came down again to talk about the area of sector. And we've been able to apply them. So I want to believe that the class has been effective. The assignment below is stated here from your new general maths SS1. Do the following assignment, and I'll be expecting a feedback from the class. Thank you. God bless you. Don't forget, submit this assignment to our Email address fgcdigitalclass@gmail.com, and the Lord will bless you. Thank you.